remote sensing apply to this issue, maybe I will be happy. Before beginning of my talk, please look at the picture. Now, this is a picture. This is a picture of result of cloud observation from geostatic satellites. But this image is a little bit different from visible data. This is the actual visible data of cloud observation. This data is on 8th November, beginning of this month. So, but this is observation data on daytime, but we cannot see the around here. Most part is we can see, but this part is almost nighttime or something, so we cannot see the cloud. But this one is same time, but infrared data, with infrared sensor, so we can see cloud around here. Using infrared sensor, we can see cloud all over day. So today's keyword is maybe infrared sensor observation with infrared sensor, I think. I will start this agenda. Firstly, introduction. Last century, last 20th century, debate of aircraft have provided us remote sensing technique, and the development of satellites has accelerated the progress of remote sensing technique. So, in this presentation, remote sensing is used as the same meaning of Earth observation with satellite and their applications. So, I call them satellite remote sensing. And special satellite, two kinds of satellite in this picture. This one is a geostationary satellite. Previous picture gets this kind of satellite, but today's in my talk, I will focus on another kind of satellite, named LEO satellite. It is a low Earth orbit, low altitude orbit satellite. In satellite remote sensing, we often use this kind of satellite. So I will focus on this satellite today. This is an image of orbit, 36,000 kilometers from surface. We have geostationary satellite orbit, but LEO satellite around here, maybe 700 kilometer from about 700 kilometer or 10,000 kilometer from the ground. Next is I will talk about the advantage of remote sensing. Most important, the most remarkable advantage of remote sensing, satellite remote sensing, is that we can observe phenomena in wide area at the same time, like photography, as seen previously. It is a very remarkable advantage. But disadvantage is it has a limit of resolution because very far from the target, like a satellite of 700 kilometers. It is very far from the target, so it has a limit of the resolution. Maybe ordinary observation have 10 kilometer or 100 kilometer resolution, but now we can use less than 10 meter resolution images. And most important disadvantage here, we cannot measure physical condition directly. Using remote sensing, we just measure electromagnetic wave only. So this is a sample image of remote sensing. This one is another resolution of remote sensing. This one is a very this is the most highest resolution maybe we can use. So maybe I don't know the dengue surveillance issue, but it can be said that mosquito is too small objects, so we cannot see them from satellites. So, but this is the important thing is we cannot see from mosquito directly, but maybe by using satellite remote sensing, we will estimate the area mosquito lives in. Move on next, and today next I will explain the basics of remote sensing. Firstly, I will talk about principle of remote sensing, and next talk about sensor in use remote sensing, and next satellites, and lastly I will introduce some products of remote sensing, satellite remote sensing. Principle of remote sensing. Maybe this is just my opinion, but it can be said that remote sensing is measurement techniques of electromagnetic waves, including light, sun ray or sunlight, and secondly, this is interpreting technique of measures electromagnetic wave signals. So, as using electromagnetic waves, we are able to know the condition of target at the distance place. This is a spectrum of electromagnetics. This horizontal line is the wavelength of electromagnetics. Around here is a radio waves region. So maybe mobile phone around here. I don't know. And in for remote sensing, we often use this region of microwave, and this side is almost optical region. I mean, around here is a visible region. We can see the image by using this region, but most important region is around here. Here is infrared region. This region we cannot see directly, but through the IR sensor we can visualize the image of the observed target object. Again, remote sensing is a kind of interpreting technique of measured electromagnetic wave signal. So, because measured EM waves are radiate wave or reflect wave from targets, so radiation and reflection of electromagnet are most important phenomena for remote sensing. So, I will explain this phenomena easily, simply. This is a image of reflection and radiation. So, every object radiates thermal radiation, radiates thermal infrared, because they have it's a kind of thermal energy. This is a thermal radiation, and another phenomena is reflection. Most important is sunlight reflection. Sunlight has a visible region and also have infrared region. And my specialty is around here using microwave, but today we don't explain about, just focus on sunlight reflection only. Same thing. Objects radiate EM waves of which spectra form depends on its temperature. That is Planck's laws of radiation, as you know. And another phenomena is radiation of EM waves occurs as a result of interaction between object and EMS. So we can know the condition from the EM wave signals with sensor. This is it's a kind of spectrum of some radiation. Temperature of sun is very high, maybe 6,000 Kelvin, but Earth is here around here, almost 300 Kelvin here. So sun spectrum of thermal rejection from sun have the around here peak have the peak around here, very short wavelength, maybe around here visible region. But on another hand, in case of Earth, this is their cold planet. So and we have just 300 Kelvin, maybe to 27 degrees centigrade or something. So peak they have peak around here. Very long wavelengths rather than sunlight. Move on to next phenomena. This is an image of reflection of EM waves. This is a source of EM sunlight, and object sunlight reflects object surface, and we can observe the reflect wave with optical sensor. Maybe source and reflectivity of each object combined within, and result of this interaction, we can get a reflective waves. So, analyzing this data, this information, we will be able to know the reflectivity of each object. This is a reflectivity of typical round cover materials. Horizontal line is a wavelength, and around here is a visible region. Blue region, blue band, and green region, and red region. And around here is near IR region, near infrared region. And around here is thermal radiation, infrared region. So this line, this light blue line is for water, and asphalt of road around here, and soil is blue line, and plant. Most of plants have a peak around here in infrared, near infrared region. So maybe we can analyze such kind of this analysis. So we can categorize some kind of round cover material. And lower figure shows a seasonal variation of body field. Lowest one is May. In Japan, we plant in spring season, and harvest season is almost September maybe September. So this is maybe plant season. So and June, July, August, growing up season, and September around here we harvest rice around here. So in May spring season, paddy field maybe of all of field of water. So this reflection similar to water, but as growing up rice plant, so this region is rice and remarkable rice. And after harvest, this curve, this black curve, is almost same as soil data. So using this reflectivity analysis, so maybe we will be able to know what condition or something condition or what land cover is. Next one is example of paddy field area. This is a part of local country area in Japan, and where we have many paddy fields in this area. This is a spring season and summer season. This one is lowest one is winter season after harvesting, and we have snow cover around here. In spring season, paddy field, as mentioned before, paddy field of water, so we can see the blue area. This is almost a water area, and in summer season we can see the green color area. Most of rice plant is growing up, and winter season this is snow cover area. So if you use some sensor which has characteristic spec of each wavelength. This is a spectrum, and this is it's a kind of reflectivity here, and this is a kind of sensor combination. In this case, we have four bands. We have four different sensor. This sensor can measure around here. This sensor can measure around here, and so on. So this combination will be measured this area, so we can see plant growth, and this is almost same, but and this one is many sensor. So this combination can know soil condition and plant vegetation condition. So point of view of sensor and measuring phenomena. So we can categorize three methods of remote sensing. This one is visible or visible or これ逆ですね。IR reflected IR remote sensing. And second one is thermal radiation infrared remote sensing. And last one is microwave remote sensing. This one using optical sensor, visible band and infrared band. This is measuring visible or reflected IR. Impact of this remote sensing is survey of land cover, vegetation activity or something. And next one is almost uses optical sensor, but which has thermal radiation IR band sensitivity. So it is measuring thermal radiation IR band. Maybe use temperature, ground surface temperature, or sea surface temperature, or cloud condition. This is a summary of three types of major remote sensing method. Around here, this one is a visible or reflect IR remote sensing. This method uses visible region or in around here near IR or shortwave IR region. And second one is a small thermal radiation remote sensing method. This method uses thermal IR region around here based on far IR region. And third one is a microwave, but this method uses microwave region. So next one is satellites. We have many satellites named Earth observation satellites. So if I will list all of satellites, so we cannot list up. So, but most major satellite names are just listed. Spot, Landsat, MOS1, CEReS1, ADIOS, EOS is for visible or IR remote sensing. And thermal radiation IR remote sensing, Landsat, MOS1, ADIOS we have. And microwave remote sensing, we have ERS1, TRIM, and EOS. And this is this picture shows a sensor which is on board each satellite. Spot has a visible layer and near IR region. And Landsat have two types of sensor around MSS has a sensitivity of visible region and shortwave IR region. And another one named TM have a sensitivity blue color and from blue color to red color and near IR region and shortwave IR region and thermal region. And this Spot, Landsat, MOS1 are most major satellite, and this sensor is very important for remote sensing, satellite remote sensing. Next one is products of remote sensing. We can get raw data, linear data from satellite. This is a measured value of each sensor. This is a kind of a digital number of converted from the each sensor's measured value. Next one is index data for analyzing or interpreting. It is enhanced data using some modeling and made from raw data combinations. Last one is mapping image data. In this level, you can see the mapping data almost like a photograph and or it's a kind of a map data. So for each sensor, we have grayscale mapping, and combination of some sensors, we can have color synthesized mapping data. Index data, additional information around here. Most popular index is vegetation index and water index and soil index. This is a vegetation index definition around here. We often use vegetation analysis. We use NDVI. This is use near infrared and red region of visible data. And this is a difference of near IR and visible data of red color. And this one is water index. This one uses red and short wave IR. And soil condition, analyzing soil condition, we use soil index, short wave IR, and near infrared. Go back to this raw data. This is a grayscale final product of remote sensing, but from the satellite we have just digital number series like this. So we convert and mapping like this, so we can get a grayscale image, and this is this area is where we can see from the satellite aerial satellites. So around here we can get a grayscale mapping for each sensor. So as mentioned before, one satellite have many channel of infrared, so we can get many band of infrared grayscale map around here. This one is 400 からmaybe green or red, and これもグリーンだな。ブルー、グリーン、レッドかな。で、これが near IR region. So we have So we have a grayscale of each sensor. So and so we can color synthesize imaging data. So this is a real photograph, but this one and this one is a grayscale image of each sensor. This one is visible of blue color. This one is visible data of green color and red color. And synthesize grayscale. We locate each channel of each color. So and we can combine the color, almost same color generated.
Excuse me, Professor Osa, 3 more minutes, please.
Quickly. And skip. This is another color mapping and named forest color, and this one is a natural color. This one is very important for remote sensing, optical remote sensing. This one generate. This one make a. We put a near IR red into red channel, so we can enhance green vegetation area enhanced. So. And finally, we can we will use this colored map or index data. We can generate it's a kind of a land cover mapping. This is a final, almost final product of remote sensing. So using this material, maybe GIS analysis can be used. And so we have a minute. Yeah. And so maybe we cannot see the mosquito. It is very, it is too small. But we can know the area using remote sensing. So we can see the environmental of mosquito living. Today I prepared I have an example, but I skip these topics. And finally, so using satellite remote sensing, we can estimate area mosquito lives, which has some characteristics or properties of reflectivity spectrum or something. This is a dengue fever area, maybe, and this one is a dengue fever area, and this one is a product of ground cover from satellite remote sensing. So around here, maybe this area we have ground cover of evergreen and broadleaf tree area around here. Number 1 dark green area, and or farm field area number 13 around pink purple area around here. So maybe I cannot conclude, but something we have relationship between this one and this one. So remote sensing will be it is, I can say that remote sensing has some potential of dengue survey field, dengue surveillance. So summary of potential of remote sensing. So starting surveillance, I don't have today. I don't have a solution on dengue surveillance, but in my opinion, starting surveillance is assuming an environmental model of mosquito growth, and next one is considering or designing reflection or radiation model which can explain this environmental model, and select or develop some index which explains model property well, like MDVI, vegetation index, or water index, or soil index, so on. So lastly, maybe we cannot see the mosquito, but maybe we will find we will estimate the mosquito in area through the using the remote sensing result, water content, rating, soil index, NDVI, water index on something, and land cover mapping. We can maybe we can estimate the area in the mosquito living. So and today I don't have any solution of dengue survey, but through my talks, if you find something that apply to remote sensing in this area, I will be happy. Thank you.
Yeah, thank you. Yeah, thank you, Professor Osa. I think it is a very interesting topic, and I guess most of the audience see that this is something new, including for me. But you mentioned that it may have a potential benefit also for the dengue. So yeah, now we move to the next speaker, Professor. Yeah, you can have a seat.